Hello everyone. So I'm going to present our NeXus framework at DESY. So DESY is a synchrotron facility as ESRF of Diamond, and it's placed in Hamburg. So some time ago we start to write our NeXus files. So we choose NeXus, so it's NeXus for us, it's HDF5 file, but we have additional structure. So we use HDF5 format, and then on the top of it, we structure the files in the NeXus way. So here Benjamin already explained a little bit about NeXus. So as we discussed before, we don't use application definition in order to left freedom to scientists, because the methodology during the experiment is really rapid. We have rapid changes of the methodology. So if we fix the application definitions, then we put additional bounds on science. So that's really better to, maybe it's the step when we are when we develop our let's say application definition which cover all the things, but it looks like it's process that it may takes long time, and for me it looks like it may not happen at all. So NeXus files have a lot of advantages. So we can save scalar and multi-dimensional data in single files. We have hierarchical data structure, so with tree like structure, and also we can save additional attributes which describe more our experiment. So we put more metadata into the files. So but of course it's our group. So it's experimental control provides possibility to write NeXus file on all the beamlines, but now we have additional steps of how the beamlines are configured. It depends on the beamline scientist. So beamline scientists decide what they want to have it in the file, how accurate is description, and finally the user which comes, he decides if they want to have it NeXus file or something else. So it also depends, how the beamline is prepared, yeah. And of course, on some beamlines, they do not have choice. They have to store NeXus files. It also depends on the beamline, but it's really depends on experiment, and it's really, we have a historical reason, so the user get used to store the files, other file format. Also, the very important thing is the application. So what they can do with the NeXus files. Usually with PIFs or CDFs, they already has lots of programs to evaluate. But for NeXus, it's good we have Silks now or NextPy. So now we have more and more applications to open this NeXus files, and also Jupyter Notebook. So it's Python, so is available for the scientists. They start to like it, so it's really good that they can access the data sets via Python. Okay, so now I will be more technical. So what we are using, so our NeXus libraries. So for metadata, we're using Python, so it's H5PY, and our bindings for PNI NeXus. So everything depends on HDF5 library. We are using 1.10 library, and now we have here wrapper H5CPP wrapper, which was developed by Eugen and Martin. So it's collaboration with ESS. now we are taking care as well on it. We have some additional C++ libraries, so it's high-level interface for Nexus, and as well very commonly used feature is just dump metadata or create structure of the file from XML string. So it's often used in our Tango server. So in Tango server we have defined XML strings for Nexus, and then we use those libraries just to create the structure, not to create command by command the groups and so on. So this is, and when we want to change the structure, it's easy, and one need only to change the XML thing. And of course, this TNI Nexus is a binding for all those libraries. So for metadata storage, we have some factor, and the user can choose in principle if he's using or she's using H5QI or this TNI Nexus binding. It really depends on the user. So all those things are available either on GitHub, or we have also Debian packages for all our software, so one can freely download the things. Now about storing metadata. So and the structuring the file, how it is done. So we keep configuration for Nexus file in the MySQL database. So from that is configuration server, and let's keep it in the XML strings, similar to NXDL standard, and let's keep it in the parts. And each part corresponds to some piece of device or device, so hardware device. So here we have control client like Sardana or some user script, and this control client can select what are the components, XML components are used or needed for this experiment, and match all the configuration and provide this configuration to our Nexus writer. So this is Nexus writer according to configuration. This XML format is NXDL, but it's with some extension with the tags of data, source, and strategy. So from where the data is written and at what time during the scan is written. So if it's at the beginning, during the scan, or at the end. So, and Nexus writer can get all those information and fetch the data either from our Tango server or from database, or also directly from the control client, and write it to the file server. We use BPFS mostly for storing the data. So, and yeah, so also for everything here is written in Python, and we use Nexus writer is using bindings of H5QI, as I said before on the previous transparent. So this is how it looks like in the real life. So we have control experiments as a control client, and the user select the components labeled by the names. For example, here counters or ADC or virtual counters or detectors. Apply it, and then Sardana recorder, for example, asks for XML configuration and start to run the scan. So when we select here one of these checkboxes, it doesn't mean that there is only one data source for it. So for example, for Pilatus, it's quite complicated thing. So it's not only one channel, but each this component is some kind of structure, tree structure. And so the component describes what data is written to which place in the Nexus file. So it's some kind of mapping. the hardware devices to real physics, because the structure in the Nexus describe the real physics. So data set names of the data sets and the types of classes of the groups have meaning, physical meanings. Of course, for fast detectors, we cannot do it like this, because as it was mentioned in before talks, often we get the PCs and hosts already from vendors which are complete, and it's like black box, we cannot touch them. So they store the data in their way. So, and then we have to fetch those data in someone. And now it really depends what kind of detectors we have it. So this is how we store or connect to the master file. So for 0 and 1D data, it's easy because it's not so fast. So it's we store the data in our master file. And for 2D data, it really depends. So we have some detectors, slower detectors, where we can store the data in the Nexus in master file directly. But for faster detectors like Lambda and IGA, which has they create their own HDF5 files, we try to create the links to them. So master file has links, external links to the files which are created by Lambda. Yeah, so most difficult cases are like Pilatus, which is like black box, create the TIFF and CBS, and yeah, we store those TIFFs, and after the scan we can run the script just to add the things, to add the data to the master file. Yeah, so similarly with description, so user can select description, but it's also automatically deselected. So they are component description. So they describe mostly the thing in the init mode, which means that the data is stored, it's snapshot before of the instrument before the experiment. And they are either selected or deselected automatically according to if they are available or not. We can have the user data, which is put manually in the application, and we can how it looks like when we perform Sardana scan. So it's enough to choose NXS extension, then we can store Nexus file. Here is how it looks like Lavi. So it's our visualization tool. We can use Swimmer to visualize, to look at the data, but in most cases we don't use Swimmer of two reasons. Better to firstly to get data from detectors before storing. So it's not really the data from the Nexus file. And the second reason is about our MATLAB users. So we don't use Swimmer and VDS now. We would like to do it, but because of MATLAB and IDL, we now avoid to do it. But VDS is also a very good feature, for example, for IGA files. We would like to use it, and on one beamline there is implemented, they use in VDS, but generally it's not. Okay, and now one slide more. So we create the component from the template. So just to how we create the component. So we have some templates, and then we can instantiate those templates for each beamline, and we have two groups of those templates. The one are common for all the beamlines, and then other are specific from the beamline. And depending on the names of the motors, we have some script just to instantiate all the things. And then we have script for all the beamlines, which can reproduce the configuration from the scratch. So this is about the components in the database. So we can create the, okay, and then, yeah, we have lots of scripts just to show what is inside database. And then finally, so we are producing Nexus file, and it has lots of advantages. We store 1D data and 0D data as well, metadata information in the master file, and then for others, for 2D data, fast detectors, we create external links or collect them in the post run. Then we create a beamline description also in init mode, so it's kind of snapshot before the scan, and we can we use this configuration component, so splitted XML let's say strings to describe sophisticated Nexus structure in a specific beamline. So it's really useful to have it like that, because we can easily just create the configuration for different cases, for different user groups. So, and the standard components are templated, so it's also easy to change the components in this way. If someone changed the name of the motor, it's enough to change the one name in the script and run the whole configuration. Okay, I think, thank you very much for your attention.
Questions?
I mean, you use XML to describe these components.
Yes.
Is it some kind of? I mean, we also use XML, so it's interesting to do it together afterwards and compare how we do this to see if there's any commonality the way we use XML.
But use the NXDL standard or
no? I don't. They use it. You're using it.
Yeah, no, with some extensions. So since it was already defined, we start to use it, because, and then we add those data source and strategy which we need just to have, let's say, time and place dependence of the data.
So thank you.
Yeah.